Hello, friends. Welcome to Akulmek Live. And in a couple of previous episodes, we have been learning about the industrial cables from our dear friend Mr. Naveen Toshniwal, who's the CEO of Toshniwal Cables, a very well-known company, very specialized. And we are learning so many new things about the industrial cables, which are so different from our housing cables. Today, we will learn about the cables which are used in heavy industries and defense. So, without further ado, let's welcome Naveen to our show.
Hello, Chandrakant. Hope all is well now with the summer setting.
Welcome to the show, Naveen. Everything is fine, and you're looking good because it really looks like the winters have gone. Looking at you because you're already in summer retire, isn't it?
Right, correct.
So, Naveen, I think last week you told us about so many different aspects about different shieldings and different kinds of cable and temperature tolerance, etc. Today, what is that you want to tell us, to tell our viewers about the cables which are used for defense and for heavy industries? Over to you.
See, actually, it's a very big subject because what we specialize is in developing any type of cable as per specific client needs. So I will just give you show you some samples and then describe what they are about. Now, you see this one. This is a very huge cable. It's so heavy that I'm having difficulty to hold it also. Now you see this one, this has got four conductors of size probably 95 square mm. And there are four small conductors here at the corners. These are called the earthing cores. And this is of 1/3 the size of the normal core. And this is a heavy duty power cable which is used in lighthouses in Navy applications. And the insulation here is of a special type of rubber, which is called EPR, ethylene propylene rubber. And in the center, just to give a round shape, there is a dummy core, which is made of just a plastic pipe, just to give a round shape. And thereafter, you will see that there is one sheath over here and another sheath on the outside, and in between there is a, you can say, a nylon braiding. You see the white dots. I'm not able to show you properly, but the white dots here, that shows a nylon braiding is like a mesh like this, and that is used for providing mechanical protection to the cable. Now the outer sheath again is of a very specialized material which is called CSP, chlorosulfonated polyethylene. So this is again a specialized type of rubber which is used in Navy applications, because see, these cables are laid at places where there are chances that the salt water of the sea may touch these cables. So CSP is a very good material for withstanding this sort of atmosphere. And it's a very specialized cable which we had developed for the Navy, and they have been successfully installed and running fine.
Great, Naveen. One question regarding this cable, and that is, how long this cable can be? Is this the submersible cable, or this is the cable which is used in lighthouses locally and on an island? Um can you tell us more about this?
See, I think this is not a submersible cable, because submersible cables is put below the ground. This is used in lighthouses, and I am not sure how exactly the Navy people use it, but then it must be carrying some sort of current, or some sort of heavy duty high voltage current to run the lighthouses in a proper fashion. So it is used in the air only, as far as I know, just with the provision that some portion of it, if there are some waves coming, then it touches the cable, then there should not be any damage to the cable, and it will definitely have a long life once we use the proper material for insulation.
It looks very large and very big, in fact, and it is an amazing cable. I mean, just to look at. What next, Naveen?
Yeah, see, this one is only 95 square mm. People may ask for even 120 square mm, even 150 square mm. They are even much more bigger, huge. Now I'll show you another specialized cable. Now this cable is a very heavy duty cable. It is used for carrying current up to 11 kV. This is a single core cable, just one core, and it has got a cross sectional area of 150 square mm, and it has got a semi-conducting tape. This is a semi-conducting tape, which is one of the features of these heavy duty cables. Now the conductor is of tin copper and there are so many strands, and because to maintain the flexibility we have to increase the number of strands, and over this there is a silicon rubber insulation. Now this is another type of rubber. This is called silicon rubber. Now the characteristic of silicon rubber is that it is very flexible and it can withstand a temperature of 150 to 180 degrees centigrade, whereas now normal EPR or CSP rubber can withstand only up to 90 degrees. And okay, now these are the features of silicon rubber to withstand high temperature and to get a flexibility. But the negative point of silicon rubber is that it does not have mechanical strength. Now, this silicon rubber, even if you deeply cut with a nail, there are chances that there will be a small crack coming, and which may increase even if there is some mechanical force applied to it, it may break. So the disadvantage is poor mechanical strength. So to overcome that, you will see that just over the final covering is of a fiberglass braiding. You can see the strands of fiberglass coming out. Now this fiberglass braiding is applied with a high temperature varnish. So this is something which provides mechanical strength to the silicon rubber cable. So now this cable in combination with silicon rubber and fiberglass braiding provides flexibility as well as mechanical strength, and the semiconducting tape is used for uh, to will enable it to carry very high voltages.
So, Naveen, where this cable is used, and I have few more questions about it, but the first question is where this cable is used.
See, I'll be very honest with you. We are not experts in the application, but as per my knowledge, they must be using it in their hydro generating turbines, because this is a cable which has been supplied to a hydroelectric plant. So they must be using it in somewhere in the hydel turbines where they have to run some very heavy duty motors. So application wise, of course, I'm not an expert, but I assume that they would be using it there.
And the next question is regarding your semiconducting tape, which is sort of an insulator. So why we use semiconductor tape? We can use the normal tape, even though because the current may be transmitting through the cable through the metallic part of it. Why we need a semiconductor insulator?
See, again, I'll be honest with you. I am not fully aware of the application of the semiconducting tape, but any high voltage cable above 6.6 or 11 kV, this semiconducting tape is one of the features which is prescribed in all Indian and international standards. Probably, I think I may be wrong or right, I'm not sure, but there is an effect called corona effect on such cables. So this particular semiconducting tape probably takes care of this corona effect when high voltage current is going through it.
I have one more technical question, and that is basically again I will like to ask you, and you can probably say that whether it is a relevant question or not. See, normally what I've heard is that as you said that there are so many strands in the cable. There are multiple strands in the cable, and what I've heard is that electricity do not travel through the cable, but it actually tend to travel on the skin of the cable. That is why people manufacture strands because if the cable is very thick, there will be a lot of resistance and it will heat up and it may start to burn also. So that is why the small strands are used to make an electrical cable so that the skin effect is reduced. So considering this the skin effect, and then finally it is wrapped with a semiconducting tape. So for the geeks who are watching our program, if you can throw some light, is there a relation between the skin effect of the electrical transmission and the semiconducting tape? If there is something that you can throw some light on, it will be good.
See, I think what you are saying is right. There is definitely a connection between the skin effect and the semiconducting tape. But see, actually, we are experts in cable manufacturing and cable testing. We are not really experts in the application of the cable. So, what we are told by the standards and what we are told by the clients to make, we make it. And where they use the cable, we may or may not be very familiar with the application where they are using it. But ultimately, the end need is that the cable should run very satisfactorily at the site. So we have to ensure that each and every parameter or specification as per the standard is followed in complete details.
Fine, Naveen. One question is, when you make such large cables and very thick cables, you would need very heavy machinery to maintain these cables, isn't it? I mean, to fabricate these things also, you need very high-tech machinery or maybe very heavy duty, um, maybe a very big plant. How big, machines you need to have in your factory to develop these kind of cables, which are very, very large to look at?
Yes, Chandrakant, you are absolutely right. Such heavy duty cables or heavy weight cables, in fact, need very specialized machinery for handling. And of course, skilled manpower is required, how to adjust the drums and how to roll it here and there and how to fit it properly in the machines. So that itself is a very big task. But of course, over the years, we have got experienced and we know how to handle such huge cables also. It's not easy. It's not easy. And with a small plant of our size, we may not be able to give a single length of more than 50 meters, because once you start winding, the drum will become so huge, the volume will be so huge that anything above a certain weight or volume will not be able we will not be able to handle in our plant. So we have to give in cut lengths of 50 meters or 100 meters, and we tell the client in advance, okay, this is what we can do. So you have to plan your laying of the cable accordingly.
So, Naveen one very small question, very childish type question is that once it is a 50-meter length cable that you have given, which is a very, very thick and very heavy duty, and the application could be longer. I mean, the client would not, need 150 meters, for example. So, in that case, there will be a coupling between the different lengths of these heavy duty cable. When it is like a small cable, we know that we can twist it and probably weld it or maybe solder it. But in these cables, how these cables of different length are connected with each other?
Because I would not be having a knowledge of how these plants. Hello. Yeah, because I will not be aware how they would probably connect these cables at site. But as you are right, the small cables can be welded and they can be twisted and they can be made to operate like this. But normally, as per my experience, such heavy and big cables are never used in such continuous lengths. Maximum they would be cutting it in pieces of 10 meters, 20 meters, and accordingly they will be fitting it to their motors or to their machines.
So the cable which is used for electrical transmission and what we see outside our homes, which is also very thick. But Is this cable which is outside for electrical transmission is a specialized cable, or it is a normal cable from your point of view?
No, what we use for transmitting electricity in our houses are the one which is coming from the pole up to the main meter. Those are made of aluminum. And normally the cables which are used inside the house, they are thin of in size, and they are using copper as the conductor. So these cables are totally different. The application is different, the construction is different. What we are talking about here are cables for industrial use, and they are very, very specific to meet the client requirements, and they are made specially as per the site requirements of the clients, and every customer and every order will be totally different from others.
Yes, understand, Naveen. In fact, I want to tell the viewers that it is so flexible and so complicated at the same time that each environment will impose new challenges. And say, for example, a plant is coming up somewhere, then the soil specification, weather, and also sometimes gravity may have an impact. And those specifications are given to companies like Toshiba cables, so they can produce the right cable with the right insulator, right right covering, coating, weatherproof, and also the right material for conductor. So it was such an amazing journey we had with you, Naveen. You already told in the beginning that it's a very vast subject, but I think we could simplify as much as we could for the benefit of viewers. It was a great learning talking to you, Naveen.
My pleasure to you. Thank you very much.
So we will catch up with Naveen next week, same time. Until then, I like to say goodbye for today. Just in case any viewer has any question, they can shoot out the email to us. The email address will be given at the end of the program, or you can reach out to us on LinkedIn or Facebook, or you can reach out to Naveen Toshniwal, CEO of Toshniwal Cables directly. So, viewers, I will end the video today only to catch you in the next one.